Now we're going to shift our attention to TCP, the Transmission Control Protocol. Now, TCP is interesting. It's where we're going to spend most of our time when talking about transport layer protocols because it's quite a bit more involved than UDP. We talked about UDP and how it was really almost kind of a pass-through protocol. The transport layer is most closely associated with reliability functions, but UDP actually doesn't provide any of those. It's what you use when you want to pass those features upstream to an application layer protocol or when you just don't need those types of features at all. TCP, on the other hand, is really the embodiment of a true transport layer protocol. It's robust in the sense that it provides all those different reliability features we need. Now, when I talk about reliability, I'm talking about things like error detection, self-recovery, dealing with high latency networks, things of those nature. That's when we want to use TCP, is to ensure packets get delivered to where they're going across any type of network in a lot of different circumstances. So this is when we're concerned about packets being in order, being sequenced together, and if we drop a couple, we want to get those back. We really need those. So TCP is the true embodiment of transport layer protocols in that way, and as a result, it's much more complex than UDP. We'll see here in a minute when we look at the protocol header. There's a lot more fields, and to be able to deliver all these different reliability functions that we need a much more complicated header and quite a bit more variance in the types of stimulus and response we can expect. Now, TCP is defined in RFC 793. It's by no means a new protocol. It's a pretty common protocol, an older one, but it's an important one, so we're going to spend quite a bit of time on it here. This is the TCP header, and as I mentioned, it's a lot more complex. We have a lot of different fields here. Certainly, it's a lot larger than the UDP header. The UDP header was only 8 bytes. This one you can see is quite a bit larger than that, and can be even larger if you take advantage of the options section down there on the last row. And quite a few hosts do. It's not unlike IPv4, where you're not generally seeing hosts use those options. With TCP, you do see that often. Most hosts will use a few different options, and we'll certainly talk about a few of those. But the TCP structure is a little bit complex. We're not going to talk about every single field. Again, the goal of our course is to be practical. We're going to talk about the fields that are actually used and important and the ones that you're going to see. We're not going to talk about some of the more obscure ones or the ones that are unused in most situations. So we'll go through each of these. I'm going to go through them actually pretty quickly at first because then I want to get straight into stimulus and response and show how a lot of them work. It's a lot easier to see how these fields work when you're actually looking at data and seeing how things interact. We'll also save a couple of fields for a later module where we're going to talk about latency and examining latency. TCP has a lot of cool features for recovering from latency, so that's where we're going to talk about those in the context of that discussion and how to analyze and troubleshoot those things. So with that said, the first couple of fields we want to talk about here are what you would expect, the source and destination port. You see those on the first row there. Source port is at TCP 0, destination port is at TCP 2. Those are each 2-byte fields, which is why we have that maximum value of 65,535. And in this case, they work the same as with UDP ports, right? Our discussion of ports earlier still applies. Services will bind to a listening port, which is where a computer will communicate with. It'll know what that listening port is, send traffic to that while defining its own source port to receive communication back on. Of course, with TCP, we're concerned with two-way communication, especially since we see a lot more of that with TCP, whereas UDP can definitely be one way in a lot of cases. With TCP, we have acknowledgments that have to come back. So this is even more important in TCP, which is why source ports and destination ports are important.